Hello everyone, my name is Weston Buchanan. I am a PhD student in astrodynamics at Purdue University. I will be presenting on aerial platform system design for finding life at Venus. Recent developments in the scientific community have heightened interest towards the investigation of the Venusian atmosphere. One such development is Professor Jane Greaves' potential discovery of phosphine, a molecule which, on Earth, is exclusively associated with life. Moreover, reanalysis of Pioneer 13 mass spectra shows further signs of disequilibria in the clouds. Thorough investigation of these anomalous observations demands aerial platform technologies that enable in situ analysis of atmospheric samples. MIT's Venus Life Finder Mission Concept Study, led by Professor Sarah Seeger, proposes two mission concepts involving such analysis. The aerial platforms proposed to accommodate the science payload for the Venus Life Finder mission are constant and variable altitude balloons developed by Thin Red Line Aerospace. The bases of the constant and variable altitude balloons are equivalent: a helium superpressure balloon coated in a 5-layer laminate operable to 135 degrees Celsius. The envelope features an acid-resistant cloak and is fitted with pressure restraint tendons. Planar fabrication reduces trauma during storage, transit, and deployment. In the case of the variable altitude balloon, the modular design allows segments to be stacked on top of one another to form a column. A cable is passed longitudinally through the column and fixed to a stepper motor located at its base. The buoyancy of the balloon is increased and decreased by lengthening and shortening the cable. For any given altitude, the tension cable load ensures superpressure in each segment in order to maintain envelope turgidity. This provides instantaneous access to altitude control while simultaneously increasing the durability of the balloon. The aerial platform is housed inside an atmospheric entry system featuring a blunt 45-degree forward aeroshell heat shield. Behind the heat shield lies a spherical pressure vessel to protect the science instruments from the harsh Venusian environment. The aft shell conceals a parachute which controls the descent of the balloon system until the envelope is inflated, at which point the inflation system is jettisoned. The aerial platform then rises to its initial science altitude and begins operation. In the case of the variable altitude balloon, the system will vary its altitude within operational limits for the duration of the mission. For a given altitude band, the mass and volume of the variable altitude balloon system increase substantially with altitude. Restricting the altitude band, from 10 km to 4 km let's say, reduces mass and volume considerably. Regarding the constant altitude balloon, the absence of a flight control system along with its smaller size result in much lower mass and volume numbers for a given payload. This design comes at the expense of active altitude control, but permits higher science payload mass.